Walter Isaacson, welcome back to Authors at Wharton.
Wow, it's so great to be back with you, Adam. You're the man.
Well, that remains to be seen, but you didn't have to travel as much this time, so we tried to make it as easy as
Oh, I
possible.
love Pennsylvania. I love Philadelphia. I love the University of Pennsylvania. I'm a Ben Franklin guy.
Well, you're an honorary Quaker. You're welcome back anytime. I am so fascinated by your newest book, The Code Breaker. I have so many questions about it. I hardly know where to start, but I think the most logical place to start is where you started. How did you end up writing this book?
Well, I had done a book on the physics revolution of the first half of the 20th century with Einstein's theories leading us to everything from space travel to the atom bomb to GPS. And then the second half of the 20th century, you and I grew up in it, it was dominated by the digital revolution with the internet, the microchip, and the computer. And I realized that this new century, the first half of the 21st century, is going to be dominated by a life sciences revolution. And I met Jennifer Doudna about 7 or 8 years ago, and I thought she's the perfect central character for such a book because, you know, she, as a young girl, had read The Double Helix and decided she wanted to be like Rosalind Franklin and, you know, discover the structure of DNA and RNA. And then she figures out how RNA is the beginning of life on this planet. Then she figures out how to make a tool to edit our genes. And now, of course, we're using RNA as a messenger to make our vaccines inside our body to fight COVID. But she also took the lead in the ethical issues, like should we be editing our genes? And so it's a wonderful journey of discovery with this interesting person and about 10 other sort of colorful characters in the book around her, her rivals or her partners in this. And I just wanted to do a journey of adventure about the most important technology we're going to have in this first half of this century.
Well, it is a hell of an adventure. And I know you started writing it before COVID. So it was unclear at that point how central RNA was going to become to the daily conversation.
It's a beautiful molecule.
I think that's definitely one way to describe it. I never would have called a molecule beautiful before all this.
Hey, I just got mRNA vaccines. I was in the clinical trial, and every time they put a needle in me, I said, that's a beautiful molecule.
Well, let's zoom out a little bit from the molecular level and talk a bit about what makes Jennifer Doudna tick. Obviously, an extraordinary creative thinker, much like many of the other innovators you've studied. What did you learn from talking with her, watching her up close, interviewing the people who have been in her orbit?
You know, she is somebody who's very persistent. When she was in school, her counselor said, no, girls don't do science. And so she pushed herself to do science, but she also had a foot in the humanities. She loved speaking French. She loved art and music. And so I think that helped her connect. And by the way, that's like Leonardo da Vinci or Steve Jobs or Benjamin Franklin. They both have a foot in the humanities and in technology. And that's kind of what does things that are truly creative, that truly connect to us, is if you're in those realms. She's also a great collaborator and team builder, but she's got a competitive streak. Part of the book is about her competing very strongly against the guys at the Broad Institute, Eric Lander and Feng Zhang, and trying to race them. She and her partner, Emmanuel Charpentier, are in a real race to figure out how do we make this tool that will edit our genes.
And what's the motivation behind winning the race?
You know, that's a really wonderful question because all of us have a mix of motivations in the life. And part of it was patents. They're still in a patent battle. Part of it is prizes. Jennifer and Emmanuel end up winning the Nobel Prize. That's the big one. But I think when they turned their attention to COVID, they put aside a quest for patents. They put aside a quest for being the first to publish. They put aside a quest, you know, for prizes. And they said, we're really in this because two things. Nature is beautiful. And secondly, nature, when you unlock her secrets, is very useful because we can help humanity. We can help people by understanding things. And I think they were mainly motivated. This may make me sound naive, but all the scientists involved were motivated by pure curiosity about how things work and then how to turn that into tools that will help humanity.
Well, it's a great example of what Donald Stokes called Pasteur's quadrant, right? Saying,
Yeah.
look, you don't have to choose between doing basic science and applied useful research. You could actually treat that as a 2x2 and live in the cell where you generate fundamental knowledge and you solve major problems in society. It sounds like from your perspective, that was a little bit of a sequence, though, that the curiosity to understand came first and then the application followed.
Yes, it did, but your question is incredibly good because we have a too simplistic theory of innovation that comes down from Vannevar Bush, who was a science advisor to the president during World War II, which was, as you said, a linear model. Basic science leads to discoveries, leads to inventions, leads to practical applications. And to some extent, CRISPR was that way because it was driven by the basic curiosity about why do bacteria have these clustered repeated sequences in their DNA? Nobody thought that would be necessarily useful to understand, but all these people were trying to understand it because it was one of nature's beautiful mysteries. But then it becomes useful, and it becomes useful early on. So it becomes an iterative process. Two of the people who worked with Jennifer Doudna to help figure this all out were two guys at Danisco, a yogurt and cheese company, because yogurt and cheese depends on bacteria cultures, as starter cultures. And these bacteria keep getting attacked by viruses. And they discovered by looking at the historical sequences over the years of the bacteria they had used in the starter cultures that what CRISPR was just a system where bacteria take a mugshot of viruses that have attacked them and weave it into their DNA. So if they get attacked again, they can cut it up. They can cut up the virus. And so it was this iterative dance between applied science and basic curiosity, where, like the Louis Pasteur model that you very smartly pointed to, you can be doing both at the same time.
Well, I think we need both at the same time more than ever now. I also like this picture that you paint of the dynamics of competition and collaboration happening simultaneously. I think a lot of us take an either or view. And it reminds me a little bit of a psychologist, Jessica Tracy, who has spent her career studying pride. One of the things she wrote that stopped me in my tracks was she said, we don't just want to discover knowledge, we want to be the one who found it. And all of a sudden, for me, it took the noble motivation of a scientist and added in this flavor of, but I still want to outdo my peers and my competitors. What did you see around when competition became healthy versus unhealthy, watching this race unfold?
Yes. Well, as you know, competition is not just in the industry of sciences. I mean, I was a journalist. All we did was aim for the scoops. We wanted to get it first. And that's true whether you're in business or running a track meet or doing almost anything else. There's a lot of competition involved. And with science, it's a team sport. The creativity of science is a collaborative effort. So you have to be able to put together teams the way Jennifer did. And as you said, in my book, there's a lot of tension between the competitive aspects of it and the collegial aspects of it. And I think patents distort the process somewhat because the mix of cooperation and competition in the race to discover the gene editing tool was done in a sort of collegial way. But when it got to filing for the patents, you have to have one inventor who's put on that as the main patent inventor. And I think that's the main distortion that came. We saw that in the digital revolution when Texas Instruments and Intel both invent the microchip, and then they get into a horrible patent battle about it. Fortunately, Bob Noyce and Jack Kilby then just called and shook hands and said, hey, let's quit fighting over divvying up the proceeds until we finish robbing the stagecoach. And they just cross-licensed their patents. I think that it was good that COVID helped remind people that this was a noble endeavor they're involved in, and that the patents had helped poison the collegiality of what should have been a more cooperative field. I mean, I've been at Penn and the Pennovation Center. I remember the opening of it, and we were talking about what you just mentioned about basic science leading, being translated into, translational medicine, useful, practical applications. But that interactive dance at places like the Pennovation Center, where you have basic research, but you also believe in the practical applications, that requires the collegiality and teamwork so that different people can be part of the process. And even though you want to compete, you don't want the competition to spoil the process.
Yeah, and that reminds me of one of the other themes that I loved in the book, which is this duality of, on the one hand, Jennifer and her colleagues are extraordinarily goal focused. On the other hand, they take these random walks, these detours in directions that don't seem necessarily that productive. And I remember I think it's chapter 7 when you wrote about twists and folds, explaining, the science, but also the twists that are unexpected in the career path. What's your sense of when you want to stay on the path versus when it's worth taking that detour, and how does a great scientist like Jennifer Doudna think through that dilemma?
When Jennifer was a young girl, she loved playing soccer. She grew up in Hawaii. And she said that all the boys in particular always ran directly to the ball, but she liked playing a position in soccer so that she could stick to her position and sometimes, have the part of the field to herself. And so when it comes to the 1990s, when she's a graduate student, most of the people in biology are very excited by the Human Genome Project, sequencing the DNA of the human genome. And it was run by a lot of alpha males, people like Francis Collins and Craig Venter and Eric Lander and many others. And a few of the women, mainly Jennifer Doudna, but Emmanuelle Charpentier in France, Julian Banfield at Berkeley, decided to focus on RNA, which, as we mentioned, is this beautiful molecule. And RNA is the less famous cousin of DNA. I mean, DNA is on the magazine covers, but RNA actually does work, like sometimes a less famous cousin has to do, which is the DNA just sits in the middle of your nucleus curating information, but the RNA gets that information, acts as a messenger to bring it to the region of the cell where you build proteins and says, build these proteins. Or it does it as a guide to tell an enzyme to cut something up. So by forging their own path, especially Jennifer Doudna, she ends up discovering the structure of these key RNA molecules that can replicate themselves. And her advisor said, when you're looking at science, when you're looking at anything, always keep in mind the big question. And Jennifer said, well, what's the big question here? And the advisor said, how did life begin? What's the origins of life on the planet? And so her RNA studies showed, along with that of her advisor, that by being able to replicate itself, RNA was how life began on this planet.
I have so many questions about this. I want to just zoom in on the gender theme for a second, because it's been a bit of an arc in your recent work. You spent a lot of, I would say, your early books profiling great men of innovation, and then you've turned your attention increasingly toward women, first with the computer revolution, and now obviously here in the world of science and CRISPR. What have you learned about what it takes for women to break through a lot of the glass ceilings that still exist in the world of advanced technology? And how would you like to see us reinvent science so that we don't see these kinds of barriers in the future?
Well, first of all, women need more role models, is why I wrote about Ada Lovelace at one point, because there's so few women leading the digital revolution, but there's so much talent that's being squandered because of that. And likewise, when Jennifer Doudna, as a middle schooler, read The Double Helix by Jim Watson, her dad had just left it on her bed, and she thought, oh, this is a mystery story, I'll read it. She discovers Rosalind Franklin, the woman who did the imaging work that Watson and Crick used without her authorization to do the structure of DNA. And she said, oh, I get it. Women could become scientists. And she said if she had not noticed that character, she would have just studied French, which was what she was interested in that. But having a role model made her want to become a scientist. And as I said, her school advisor said women don't do science, but she persisted because that got her back up. And I think now in the digital revolution, there's still very few women in great leadership positions the way they should be. In fact, I just finished teaching today's class at Tulane. I teach the history of the digital revolution from Ada to Zuckerberg. And one of, as a project, they all have to write a, paper. And one of them said, I want to write about the most important woman in the 80s and 90s in the digital revolution. And there weren't a whole lot of people to choose from. In the bio revolution we're entering, because of people like Jennifer Doudna serving as role models, and I hope my book is something people will leave on their bed for their daughter or their niece or their nephew or their son to say, here's a role model. But at least now, 50% of the women doing the people doing postgraduate work in biology are women. So I do think that pathway is now open. Where it's not as much open is when Jennifer decides to start a company like Mammoth Biosciences based on CRISPR, or CRISPR Therapeutics that Emmanuel Charpentier did. You go into a room of venture capitalists and she said it's all men. And then they start suggesting men who can run the company for you. And so I think you know this world incredibly well, but the world of venture capital is one where women still have trouble getting the investments they need.
Yeah, we have a lot of work to do there. And it seems like the world of venture capital has also been very slow to recognize the importance that that these biological technologies are going to play in the future innovations of the world.
Well, I
Now,
think maybe the coronavirus vaccine and mRNA set their heads straight. Certainly Moderna, which is a great venture capital-backed company up in Cambridge, Mass., they're setting the way for maybe we should look at this biotech stuff more carefully.
it is about time. If we can count that as a potential silver lining of COVID, I think it'll be good news. I want to talk about CRISPR, Walter, because this has been obviously a very controversial question for a long time, even before we had the science and technology. Philosophers and ethicists asking, is it right to edit? Should we even consider doing that? How do you map the evolution of thinking on, is CRISPR a good idea or not?
Well, you have to ask the question, is it immoral to edit our genes? And then you have to ask the question, would it be immoral not to? I get emails all the time now since this book came out from people saying, here's a picture of my 12-year-old granddaughter or my 9-year-old son, and he's got cystic fibrosis or she's got a rare congenital disease. Can you get me in touch with Jennifer Doudna? They say he may die or she may die in 2 or 3 years. And your heart just, leaps. Also, when you look at what we went through with coronavirus, if we can find ways to edit our genes so that we're less susceptible to viruses and we can do it safely, that's something I think we ought to consider. But I think we ought to draw the line for the time being so that we don't make inheritable edits. In other words, heritable edits that will be passed on to the children and everything, all the descendants. I think at the moment we should focus on doing it in individual patients, which is much safer, more expensive, but much safer, and patients who can give consent. There's certain things where I worry about the ethics of editing the human genome. I don't want the rich to be able to buy 6 more inches or 2 more IQ points for their kids. I don't want to, I'm sitting here right in my house on Royal Street, New Orleans. Even tonight, it's like packed with all people, short and tall and fat and skinny and gay and straight and trans and deaf and different, hues of skin color. And that diversity is really cool for our species. And if we sort of allow a free market at the genetic supermarket where everybody can pick traits for their kids, I just don't want us to have a genetic elite and then editing out diversity. I think we have to be respectful of not flying too close to the sun as we snatch this fire from the gods.
Yeah, I think that's such an important line of thinking. And, it raises questions about whether there are dimensions of diversity that we do want to weed out. So, if we could democratize this technology, should we raise everyone's intelligence? Should we raise everybody's physical strength? Is there a case against that?
That's the George Church, wonderful biologist at Harvard argument, which is he keeps saying to me, explain to me if, I could give my kids, 10 more, 20 more IQ points and make them taller and, make them stronger. What's wrong with that? And especially if, it was widely available, what's wrong with that? I think we have to look, and in my book, I do this case by case. I mean, take height, for example. That may seem really good if you're allowed to add 8 inches to your kid and, you can have a basketball player. But, what happens if it's widely available to everybody? Then it's actually not quite as valuable because it's a positional good. If your kid's 6'8" and everybody else is 5'8", maybe that gives him a positional or her a positional advantage. But if everybody's 6'8", especially given the size of airline seats, nobody's really helped much. Nobody has an advantage except for perhaps carpenters who raise door jambs. On the other hand, if we could make everybody less susceptible to viruses, that would be a great thing. And maybe if we could raise everybody's IQ, that would probably be a good thing. Although you and I know a lot of smart people, and maybe we should pause before we go down that path. And then there are things that may seem obvious, like congenital deafness is something that could probably be edited out pretty easily. And maybe a lot of us would instinctively say, oh yeah, if my kid's going to be deaf, I want to make the edit to make sure she or he isn't. But then you might want to pause and say, is deafness a disability, or is it something that maybe enriches society by having people who are differently abled? Those are things that Jennifer and the other people in my book wrestle with. And I hope the reader, can form her or his own opinion on some of these things, because to spoil the book for you a bit, there's no last chapter saying, here's the 12 easy answers. I think we have to march hand in hand and be wrestling with these questions.
Well, I think one of the most interesting ahas that it sounds like Jennifer had during the process was, if she doesn't do this, someone else will, right? CRISPR is waiting out there to be discovered. It will happen. And so you have to ask the question, can I do this more ethically than some of my peers?
When she made the discovery, a little while later, she had a nightmare. And the nightmare was that somebody wanted to use her technology, and she goes into the room and the person looks up and it's Hitler. And that's when she starts gathering scientists and politicians and ethicists from around the world, from China to Europe and England and the United States, to say, let's all discuss what the rules of the road should be. What should we edit? What should we not edit? Where should we go slow? But as you say, sometimes people are going to barrel ahead, partly because of the competition we talked about earlier, the glory of being the first to make a test tube baby or make a clone of sheep. Well, there was somebody who used to go to Jennifer's seminars named He Zhuangqi, a young Chinese scientist. And he goes back to his town of China, works in a fertility clinic, and makes inheritable edits in the embryos of that become two twin girls. And so the world is kind of shocked because that line gets crossed. But by doing it, it caused more and more discussion. And I think even I hope my book and all these things, this show we're doing tonight, causes all of us, you and me and the listeners and the readers, to be part of a discussion about, this is really good. We don't want to stop this technology. It'll protect us against viruses. It'll make sure we don't have sickle cell or Tay-Sachs. But also, where do we want to draw the line for the time being?
One of the things that I know has been scary for a lot of people as this technology emerges is not knowing what's going to happen if we edit out some of the unintended, I guess if we allow unintended consequences, and we can't always predict the effects of our editing, right? So we may remove, let's say, a gene that causes congenital deafness, not realizing that also has the capacity to protect against some later risk factor. How do we begin to navigate those kinds of unintended consequences and unpredictable future effects?
Well, I think it's in some ways good, because they go the warning signs that say don't go too fast. For example, even editing out the receptor for HIV, which is what the Chinese scientist does, that could make it somebody more susceptible to malaria or West Nile. Likewise with sickle cell, that gene, that's a mutation, it sometimes protects against malaria in some forms. So we have to be careful that we certainly don't know the 3 billion pairs of letters in the human genome. We don't know when you start fiddling here whether it's going to mess something up there. So that means, first of all, proceed with caution. It's a slippery slope. Let's go step by step. However, we are going to be able soon, and already we've done it with sickle cell, to say, okay, we've tried it. This is safe. And one way to know it's safe is you're creating a genome. If you make the edit, you're creating a gene sequences that already exist in most people. If you fix that mutation for sickle cell, it will create a genetic sequences that are in most people that are typical of the species. So we know that that's probably safe. It's when you get into the higher order of editing that's going to take us a few decades. Like if we start taking the genes that predispose to schizophrenia out or manic depressiveness, and it's partly genetic, partly environmental, many genes add to a predisposition. But you start fiddling with those, and you may end up with people who you may make sure that there are no Hemingways with manic depression, but there also may be no Hemingways. Or you may end up messing up other things. So in some ways that's good. It means we're not going to barrel into editing our personalities, because those are the difficult edits, and that'll be a few decades before we can do them safely.
How precise do you think we can get? I know one of the things that psychologists have written about for a long time is this phenomenon of emergenesis, where you take the interaction of two seemingly ordinary genetic patterns and something extraordinary comes out of them. I always think of Matt Damon's character in Good Will Hunting as an example of this, right? You have a genius born of completely ordinary parents. And that doesn't seem like, at least currently, something we can really predict and edit. Are we going to get there?
No, I don't. I mean, we will get there, but not in your lifetime or our children's lifetime. I think it would be difficult. And yes, there are even genes that sort of predispose to autism can also predispose to mathematical genius. And, we know how that works. And we do not want to fiddle with that. We should be able to take in stride the people who are differently psychological. Even if their parents might say, "Oh, I'd rather edit them and be totally typical of the species." Well, no, that could be a problem for our species. And as you say, fiddling with some parts might mess up the magic of, a Isaac Newton coming along, or a James Clerk Maxwell, or even an Einstein popping up. The most interesting philosopher and ethicist in my book is a kid named David Sanchez. And he's 17 years old, and he loves playing basketball, except when he doubles over in pain in the middle of the court because he's got sickle cell. And so he's being treated, and the people treating him at Stanford said, with CRISPR, that's an easy genetic fix. And someday that one-letter mutation you have will be able to fix it in your reproductive cells, so your children and their children will never have sickle cell. His first reaction is, that's great. That would be wonderful. Then he says, but maybe that should be up to the kid later, after the kid is born. They said, what do you mean? He said, well, sickle cell taught me empathy. It taught me character. It forged who I am. I wouldn't be who I am without sickle cell. And I thought, wow, that's a pretty wise thing to say. But then a few months later, I asked him, are you sure you'd want your kids to have sickle cell? And he said, no, the more I think about it, I'd edit out sickle cell if it were safe. And I said, what about the empathy? He said, well, I would want to teach my kids empathy, but I would not want to cause them the pain that I've had to suffer. And so that doesn't give you the answer, but it shows you we should have first thoughts, second thoughts, then third thoughts. And I mean, you have a book called Think Again.
I don't know, Walter. Sometimes the first thought is a lot of work.
Sometimes the first thought is a lot of work, and sometimes you want to be like Malcolm Gladwell and go with the blink. But sometimes you want to be like you and say, yes, if we're able to revise our opinions as we get more information, and that's true of moral questions as well.
I think that's such an important point, and it really goes to a couple of our audience questions. We have quite a few interesting questions here. I'm going to start, since we're on CRISPR, with the CRISPR questions. One is, do you think if a majority of Americans believe a certain gene editing function, I'll add in one of my own here, let's say the ability to fly, if the majority of Americans think it should be legal, is it right to legalize it?
Well, I think that society has to come to consensus on what we're going to do. And we should all be there arguing. I don't know about the right to fly, but editing out obesity or editing in extra hearing of, ultrasound and, supersound at different sounds. And I think it should be up to society to decide. It shouldn't be up to just the doctors or just the scientists. And here's a real question for you. Should it be up to every individual to say, okay, here's what my rules are for my kid? Or should there be some rules that society has as a whole? And if you leave it up to individuals, you'll have sort of a free market eugenics where everybody gets to pick and choose the genes they want for their kids. But there may be some things where we say, just as a group, as a society, it's like certain pharmaceuticals. We say let's regulate them. So we're going to have to not only decide how we use them, we're going to have to decide who gets to decide.
Well, and this seems to become very complicated as we think about each society or each culture making its own decisions that way, right? Pretty soon, it almost sounds like an X-Men movie where, well, if the other side is going to have these powers, we need them too.
Exactly. And that's why Jennifer Doudna has been leading this international discussion with people from China who I know. Duan Qingpei is part of the academy there. And they're trying to get everybody on some common ground. And that common ground has certain basic principles that I think the Chinese, the Europeans, we've agreed to, which is, first of all, let's not make inheritable edits yet. And let's not do it for a while, because those are the ones that are more difficult. That can create subspecies of genetic elites and genetically deficient people or something. That's really a road we don't want to go down. Secondly, let's focus on things that are curing major deficiencies or genetic problems or disabilities, and not do things that are enhancements. And there's a blurry line. But let's say somebody has a gene causing really stunted growth, and the child will grow up to be 4'6" tall. Now, leaving aside, whether you think maybe society's better off to have people like that, as a parent, you don't want your kid to be 4'6" tall. So if you could add 8 inches to the height, and the child could be 5'4", 5'6", or whatever it would be, yeah, you'd probably say, let's do so. But let's say you're having a child who's going to be 5'8". Should you be able to add 8 inches to that child's height to get a child that's 6'4"? That's the difference between a treatment for disability versus an enhancement for a typical species person. And I think we should stick with treatments for disabilities first.
Yeah, that seems like a safe way to go. And it's like a societal version of the sports conversation that's unfolding about performance restoring versus performance enhancing treatments.
Exactly.
Okay, so I want to ask you some research questions that our audience has brought to the table. One question is, how do you decide who you write about?
Well, as I said earlier, I wanted to do the revolution in healthcare, the genetic revolution that begins in 2000 with the sequencing of the human genome, has culminated in 2012 in my book with the discovery of how you use CRISPR to edit human genes, and then the mRNA vaccines that are reprogrammable. So I wanted to do that. And usually there's a big, obvious character. But in this case, I cast around. I met a lot of people, George Church at Harvard and Feng Zhang at MIT, and various people in this field. And the more I got to know Jennifer Doudna, the more I realized I didn't want to just do a biography of her. This isn't just a biography of her. This is a journey of discovery in which she's the central character, but is a group journey. There are lots of other players, very colorful characters on this journey. So I used Jennifer Doudna as the narrative central character, but in a posse of people who are going on this journey of discovery, either cooperatively or sometimes competitively.
There are a bunch of questions about your research and writing process here. Let me start with one around building trust and relationships. I think when you profile someone, there's a bit of a conflict of interest in that your job as a journalist is to be accurate and fair, and the person you're profiling wants to be seen as positively as possible. How do you go about navigating the introduction, the initial relationship building, so that they do open up to you and you get the honest look as opposed to the biased look?
People like to talk, and they like to talk about themselves because it's like their favorite topic usually. And one of the things I learned here in New Orleans when I was about 17 years old and a summer intern on the Times-Picayune is that even at a crime scene, you knock on the door and you talk to a family that's been involved in a pretty horrible incident, and they invite you in. They want to talk. And the best way to get people to trust you is you trust them, and you just listen and you say, tell me about it. You don't have to ask gotcha questions. And so I think that's one of the things I bring to the party is an old-fashioned newspaper instinct of knocking on doors and just saying, tell me about it, and listening.
Yeah. And then when you start to do your research, what does the writing process look like? Some of our students want to know, do you write as you go? Do you do all your interviews and all your information gathering first? How does that unfold?
I mainly do a couple of years of true information gathering. And in this case, when the subject's alive, whether it was Steve Jobs or Jennifer Doudna, you ride alongside them. You're in their lab. You're reading all the papers they wrote. You're looking at the letters and the things that they did, and even hanging out at their meetings, and you're gathering that information. Second step is I believe very strongly in narrative chronology, that you start and you do it in a chronological narrative way. So I organize all my notes based on this happened and this happened, and here's the next year, and here's what happened. Because one thing does lead to another. Jennifer doing something on RNA when she's in graduate school leads her to meet Julian Banfield and say, well, let's figure it out in bacteria. And so you want to keep things in order. The editor I had, to whom I've dedicated this book, was my editor for 40 years. She just died a year and a half ago. But she always used to write a tigta in the margins of my outlines and notes, which stood for all things in good time. Don't get ahead of the story. Don't flash back. Just do it chronologically. And I said, well, that's amazing. That's such a great technique. And she said, I didn't invent that technique. The Bible did. That's how we tell tales. We do it through people and through narrative storytelling. She said, and remember that the Bible has the best opening sentence ever. In the beginning, comma. So follow those rules. And whenever you're stuck, just say to yourself, let me tell you a story, and make it a narrative story.
Walter, one of the things I admire most about your writing, and it's clear in The Codebreaker, but I've seen it in all your books, is you do as much as anyone I've ever read to live the Vonnegut philosophy of every sentence either reveals character or advances action. Mm-hmm. It is so hard to do that, though, when you're in the middle of all these stories and people's lives. How do you figure out what's worth covering and what gets left on the cutting room floor?
Early on, I wrote a book that's not very famous with a close friend of mine called The Wise Men. We were basically just out of college. It was about 6 friends and how they helped shape Cold War foreign policy. And Alice Mayhew, even back then, was our editor. And she said, the mark of a good book is not what you put in, but what you cut out. And she said, and she cut out all these parts about the World Bank. I said, we spent so much time understanding the World Bank. And she said, cut it out. It's not advancing the action. And so the only way I can make a story good and advance with each sentence is I read it to myself, sometimes out loud, 10 or 12 times every time I have a graph. And I try to take out sentences, take out words, find a word that's not advancing the action or not revealing character, and you can cross it out. When I was at Time magazine, there was a process called greening, because this is in the days before we even worked on computers. And you'd have your story, and then at the end, you had to make it fit into the page or two of the magazine. And you had a green pencil to take out words to make it fit. And by greening a story, you all of a sudden noticed how much better, faster paced, more exciting the story got. And so whenever I'm finished a book, I say, okay, I'm now going to cut out 15% of it before I even turn it in. And that puts me through what I call my greening process.
Well, that goes to a few of our student questions on journalism. You mentioned your time at Time Magazine, ultimately as editor. You ran CNN. You also had a very interesting look at journalism through running the Aspen Institute, which works very closely with journalists. Do you think a truly independent, objective news outlet can ever exist? And if so, how do we build it, is the question.
The answer is yes, in the sense that we can aspire to that. And I know people say there's no objective truth, but we aspire to find the truth. And every one of us knows from the minute we get up and say the first thing to somebody we meet, whether we're aspiring to tell the truth or not, or trying to mislead, whether we have a hidden agenda or whether we're just open-minded and curious. I was so fortunate to grow up in a period of journalism where I worked on a daily newspaper. And we weren't trying to advocate things. We were trying to scoop our competitors and maybe get on the front page. So maybe we fell prey to sensationalizing things a bit. But the goal was always to find out the facts. And we lost that part. I mean, there's 100 reasons, but even the advent of digital media and social media in the late 1990s and period sort of made it so there were so many corners of the blogosphere and parts of talk radio dial and places on the cable news spectrum that people were just trying to get a passionate audience. But every person, and everyone who's asked that question in the chat room knows in their heart of hearts, that you can and they can say, let me try to figure out what's actually true here. Let me try to figure out what's right. And let me not fall behind that, what is to me a maddening slogan that there's no such thing as the objective truth. We know we got to aspire for that. And we hope our journalism can return to that, that there'll be a demand for that.
I hope there is right now. And it certainly seems like our students are asking for it more and more. One of the other things our students are curious about, we had multiple people submit this question, is if you could have dinner with any of the people that you've written a biography on or profiled, who would you choose and why?
It would probably be Leonardo da Vinci, because he exemplified an important theme in Genius and in all my books and in creativity, which is he wanted to know everything you could possibly know about every subject that was knowable. From anatomy to art and math to music to zoology, he really wanted to be curious and was, and came closer than perhaps anybody since Aristotle to know everything you could possibly know at the time. And by doing that, he would see patterns that kind of rippled across nature, because that's what happens when you have this broad aperture and you're interested in everything. Go back to my magazine days. When I was at Time Magazine, I started off as what they called a floater, which meant 1 week I'm writing in the medicine section, next week I'm writing in the music section, following week I'm writing foreign policy, then in business. And so I got to understand the patterns across, human endeavors. And to me, Leonardo did that. He was so curious, passionately curious about everything. There's a notation in one of his notebooks in the margin that I saw, there's 7,000 of those pages, but I went around looking, and it says, describe the tongue of the woodpecker. Now, who gets up in the morning and wants to know what a tongue of a woodpecker looks like? I mean, how do you even find out? You have to get a woodpecker? But Leonardo wanted to know. And I'd love to have dinner with him and even just say things like, what possessed you to want to know what the tongue of a woodpecker looks like? And how can I capture that curiosity and be that way too?
What do you think he would say in response to the latter part?
He would say, be observant. He would walk around with his little notebook and he'd look at birds and notice whether they flapped their wings up faster or down faster when they took off. And he discovered that different species do it different ways. He looked at the way water swirled around rocks and he drew it in his notebook. And then he compared it to the curls he was doing in the Mona Lisa or to the math equations. And he would just say, in his daily life, he paused over and over again. He was famous for this. And he would stop and he would observe things that you and I see, but we don't observe, like a bird's wings when it takes off, or the swirl of clouds. And so I think he would become an apostle of take a moment and just observe things that'll spark your curiosity.
I think one of the hardest one of the hardest challenges around trying to think like Renaissance man or woman today is just how much information is available, right? Da Vinci, I think, had the luxury of being able to possibly know everything that there was to know. Good luck with that now. What kinds of
Right, but
boundaries would he set?
well, I would try to sort of eradicate a few boundaries. I don't know about at Penn, although I know Penn does have great cross-disciplinary work. But at Tulane, where I teach, if somebody says, I want to major in history, I say, great, but double major. Double major in history and in physics, or in history and in music, because you want to break down the silos of learning in your department. And no, you're never going to know everything there is to know about everything possible, but you can be curious. I hate it. I really hate it when people say to me, oh, I loved your book, but I didn't think I would because I don't like science. Well, Ben Franklin would have thought you were a Philistine if you went around saying, I don't like science. We should all aspire to like things, even we think we don't like, whether it's oysters or mathematics. They each can be tasty and beautiful.
On that note, I'm really curious about taking this back to Jennifer Doudna for a second. What similarities and differences you've seen between her and Da Vinci, Ben Franklin, Einstein, Steve Jobs, any of the innovators that you profiled?
Well, she had the passionate curiosity, which is, if I had to say the one ingredient of creativity, and we just talked about it, the passionate curiosity, the based on observations. Growing up in Hilo, Hawaii, she collected seashells and just was puzzling and curious about why do they spiral the way they do. Well, Leonardo did that too in his notebook. Ben Franklin does it and discovers the Gulf Stream because he's taking the temperature and studying spirals of water. So I think that's what they all share. I think she shares with Ben Franklin the ability to be a collegial team builder, because that's so important in pursuing knowledge. And Franklin wasn't the smartest of the founders. That'd be Jefferson or Madison. He wasn't the grandest of rectitude like George Washington, or the most passionate like Sam Adams and his cousin John. But he was the builder of teams. He was the person with the mulberry bush in his backyard who could gather people and sort of calm down their enragements and bring them together. Jennifer has that talent as well. She likes collegial teams, unlike Steve Jobs, who liked to form teams that were filled with creative tension. That's two different ways to form teams. I think they both work, but you have to look into yourself, say, which way is my way?
That goes to another audience question, which is innovation and leadership often require, if not competing, at least different skill sets. What advice do you have for creative people to grow into leaders? And on the flip side, for leaders to become pioneers?
Well, first of all, you don't have to do it all. In other words, great innovations are not necessarily done by great innovators. They're done by a great team. To answer your question directly, you take a great visionary innovator like Bob Noyce, and somebody who had a sense of the future, like Gordon Moore of Moore's Law. Well, they become partners. But you know what? They can't actually manage and be executives of teams. They can't be great leaders because they're too nice. They're just sitting there having ideas. So they have to bring in Andy Grove, who nobody ever accused of being too nice, but everybody said he was a great leader. And so they created a leadership team, just like the leadership team of the founders I mentioned, in which they bring different talents. And when I asked Steve Jobs, what was your greatest innovation? I thought he'd say the iPhone or the original Mac. He said, no, making a good product like that is hard. But what's really important is making a team that can continue to make good products. So creating that team is how I do it. Now, to also answer your question of innovators or talent becoming managers and leaders, That's hard to do, and we often make mistakes by forcing it. It happened in my life. I had a career detour that wasn't very happy. I'll say this somewhat publicly now, which is I was a very good, I thought, journalist. I could write great stories for Time magazine, and I was okay as an editor because I knew everybody there and it was a small group. But then when I was moved to CNN, I had to be a manager. I had to be an executive of 4,000, 5,000 people. And I wasn't very good at it. And I realized that my strength lay in sort of trying to come up with ideas, working with people to shape ideas, but not being a leader of a team. So sometimes you don't have to aspire to that. And sometimes the great leaders of teams don't have to inspire to be the innovators. They just have to be the people who create the environment and the impetus for people to be innovators.
There are a bunch of students who are eager to find out what your next book might be about. If
I'm
there's a
eager
topic
too.
or just a world or a group of people that you've been watching.
Well, certainly in modern day innovators, Bill Gates is somebody who spans both innovation in a wide variety of fields and then a coming to a moral sensibility. We're more in the middle of the story with, say, an Elon Musk or Jeff Bezos, which means I'm still waiting to see, how the Elon Musk story turns out, how he turns out. But all those are interesting people. I will find somebody who fits the basic definition of being interested in the arts and the sciences, of being interested in the humanities and technology, who like to be curious about all different subjects so they can see the patterns across nature.
I think we're starting to make progress, at least at Penn. I'm seeing much more enthusiasm than when I first came around this bridging of arts and sciences. And I think Amy Gutman has been a passionate champion of those kinds of bridges. It seems though it's been a little bit surprisingly coming from one direction rather than the other, though. I see a lot of, okay, we need to add the arts into the sciences and into business because, of course, we all want to try to become more creative. What's the case for the opposite? Why do artists need science?
What really bothers me is when people in the humanities talk about the need for STEAM, for adding the arts into the STEM field and say it's so important to have the humanities, so important to have the arts. And I say to them, yeah, we would think somebody's a Philistine if they didn't know the difference between a Picasso and Matisse or a Hamlet and Macbeth. And they'd say, yes, everybody should know that. And I'd say, yeah, and everybody should also know the difference between a gene and a chromosome, or the difference between an integral and a differential equation. And then the arts person or the humanities person says to me, oh, I can't do math, or I don't like science or whatever. And I say, wait a minute, then you're ceding this hallowed ground, which is the intersection. You're going to cede it to the engineers and the scientists if you're not going to be willing to say, you know what? I'm going to try to understand math. I'm going to not just love the beauty of creation, but I'm going to understand how a computer works. I'm going to understand what innovation is about in circuitry. I'm going to understand why we use bits of, digital zeros and ones with circuits, with on-off switches. All that's beautiful. And sometimes they'll say to me, oh, yes, but, Mozart is so beautiful. I said, well, yeah, that's a brushstroke he used to paint the beauty of nature. And same with a brushstroke Leonardo used. But a math equation is beautiful. Visualize it. That too is a brushstroke the good Lord uses to paint how nature works. Ada Lovelace was my exemplar. She was Lord Byron's daughter. She's the beginning and ending of The Innovators, my book. And as Lord Byron's daughter, she had a great poetic sensibility. But her mother, Lady Byron, didn't want her to be a poet. Her mother didn't like Lord Byron by the time Ada was growing up. And so tutored Ada only in mathematics. But Ada combined the two, math and poetry. She called it a poetic sensibility. And she comes up with the notion of computer algorithms. And when people say math is hard, she would say, yes, but read a line of my father's poetry. Like she walks in beauty like the night. That's hard too. But we try to appreciate the beauty of both. And so I would say to people in the arts and the humanities, don't give everybody else lectures about the need for arts to be in STEAM curricula unless you're willing to see the beauty of what happens inside of a molecule, what happens inside of a cell, how a molecule works, how a gene works, how a mathematical equation works, how a circuit works.
That's such a poignant observation. And I guess it reminds me of a practical question that our students ask often, which is they understand the importance of the kind of breadth and curiosity you're describing. They also know they need to establish some specialization or expertise, and they want to know, which should I do first? Do you have a point of view on that?
I think you should go broad first. You should be a floater, like I was at Time Magazine, or a person who didn't know what I was going to major in and took many, many courses when I was in college, and for that matter, even in graduate school. And then I think it is important to drill down. But I also think, don't worry, it's they're different paths, and both can be good. The world needs lots of specialists, people who drill down really deep, and maybe people who even wear blinders and drill down really deep. And it needs a lot of Renaissance people, the generalists who can see the patterns across things. So start off, in my mind, being a generalist, taking a taste of everything at the buffet. Then if you want to drill down, or if you want to be somebody who can make the connections between the different disciplines.
Well, you referenced Da Vinci doing that, and you brought up the woodpecker observation. I have to ask you to share with us, why in the world was he so curious about the woodpecker, and what did he ultimately learn about the tongue?
I love the end of that book is the epilogue, The Tongue of the Woodpecker. And I just say this, the tongue of the woodpecker is actually 3 times as long as the beak. So that when the beak hits a piece of bark really hard, the tongue wraps around the brain and cushions it so that the brain's not injured. There's no reason, though, that you need to know that. Just like there was no reason that Leonardo needed to know that to paint a woodpecker or to paint the Mona Lisa. But he wanted to know just out of curiosity. And so I thought maybe you'd want to know, just out of curiosity, pure curiosity.
That is endlessly fascinating. I would love to live in a world where people are on alert for those kinds of puzzles and then wondering about them just for the sake of knowing.
And sometimes it turns out to be useful, whether it's the clustered repeated sequences that you're curious about in bacteria or the tongue of the woodpecker.
Well, Walter, as always, this has been a treat. Thank you so much for coming to Wharton. It's a thrill to have you at Penn, and we just need to inject your curiosity into every classroom and every brain.
And boy, same back at you, Adam, because you're the one who really, really spurs us to think different sometimes.
Well, I'll try to live up to that. Thank you again, and here's to breaking some more codes.
The code breaker.